And so welcome everyone to the August 2021 meeting for the Astronomy Fundamentals Group. Got kind of a small crowd here tonight on the meeting. Tonight we have have our typical format of having a constellation of the month and a main topic presentation. Doug Smith will be doing the constellation Fornax to start us off with, and I will be following it up with the main topic presentation on kind of giving on the NGC catalog and talking about some of the history and overview of such an important deep sky object catalog for both amateurs and professionals. And with that, Doug, we'll kick it back to you.
Okay. So I'm doing the constellation Fornax. We're getting into the real southern constellations and trying to finish up our list. We don't have that many more to go, I don't think, before we start recycling. As always, I put in a comical slide. This one showed up when I was searching for it. Comedy. I like that. What the neighbors think I see, what my family thinks I see, and what I really see. Okay. All right, so Fornax is located in the southern hemisphere. It's a southern constellation. It's an average size constellation. It ranks 41 in terms of size out of the 88 constellations, so it's right in the middle. Covers about 15 degrees in declination and about 2 hours of right ascension. It's pretty rectangular shape, like you can see in the picture there. It's wrapped on one side by Eridanus, and then borders Cetus, Sculptor, and Phoenix on the other side. It is visible from Tucson because it only goes down to minus 40 degrees, and we can technically see down to minus 58. And the best time to see it, if you want to see it, would be November and December. It was described at first by Nicholas, I'm going to butcher the name, Louis de la Caille. I'm sure that's not right. He described it as the Fournier chimique, the chemical furnace. Most of the southern hemisphere, or not most, but there's a lot of constellations in the southern sky that were named after instruments like sextants and other things like that, scientific instruments. And instead of after, obviously no Greek mythology in the southern hemisphere, but the people who went down there and looked at these constellations just decided to name them off for instruments that were used at that time. And so this was named the chemical furnace. You can see it down there in the bottom left there in the square, the red square, there's the furnace. And it's actually kind of a still kind of a thing, which was a scientific instrument that was used back then. It was first put on a planisphere in 1752. He was down there at the Cape of Good Hope putting together a catalog of southern stars. And he developed, like I said, he had 14 new constellations, and all of them except for one were named after instruments. So this thing is a still, if you like, a furnace, a still kind of thing. It's a pretty easy constellation to miss because it's not very bright. There are no stars brighter than magnitude 3. But if you look at it with binoculars, it's actually pretty rich in stars. It has 5 stars brighter than magnitude 5, but over 60 stars that are greater than magnitude 7. which is a little bit surprising that it's that rich in stars because you're looking 90 degrees away from the galactic plane. And you're looking straight up out of the galactic plane, and you wouldn't expect to see a lot of stars, but there are a lot of sort of dim stars that are there. There's a lot of interesting stars in the constellation, and I couldn't do them all. I picked what I thought were the most interesting stars to talk about. So I'll talk about the most interesting stars, if you like. So surprisingly enough, Alpha Fornax is a pretty interesting star. It's the brightest star, obviously, at Alpha. It's magnitude 3.85. And what makes this star so interesting is it has a very high proper motion. It's 3/4 of an arc second per year, which is really fast in terms of proper motion. It is moving really fast. It is a binary star. The primary component is an orange subgiant spectral type F8. It is very close to us. It's at 45.6 light years away from us. It's estimated to be about 3 billion years old. And they think that it just moved off the main sequence recently, whatever that means. The star is about twice the size of the sun and has about 5 times the luminosity. The secondary star is what they call a blue straggler. It's a blue dwarf star that has a high metal content. Beta Fornax is a really interesting star too. It's a yellow giant star, spectral class G8. It's got a magnitude of 4.5. It has cooled and it's swelled. It's 11 times the sun's diameter. It's at a distance of 178 light years. It is what's called a red clump giant, which I had never heard of before. And what that means is it has gone through the helium flash and is currently fusing helium in its core. So that's an interesting star. Another interesting star is Epsilon Fornax, which is also circled on the chart there. It's just shy of magnitude 6. It's a 5.89. It's a binary star, 104 light years away. It has component stars that orbit each other every 37 years. The primary star is very old, 12 billion years old, and has cooled and expanded to more than twice the size of the sun. And it's only got 91% of the mass of the sun. So it's an old star, 12 billion years. Kappa, up in the upper right corner there, is a triple star system composed of a yellow giant and a pair of red dwarfs. The primary star is a G1. It's a little bit, sorry, that's supposed to be massive, not massive. It's 20% more massive than the sun, a little bit hotter, 100 degrees Kelvin hotter. And the 2 secondary stars are both M-class dwarfs with a mass of about half the sun, and it's 72 light years distance. Our Fornax, which is in the other circle but not shown on the chart, but it would be right in the middle of that second circle, is a carbon star. It's on the giant branch with a lot of carbon in its atmosphere. It's a Mira variable with a period of 389 days and varies between magnitude 7.5 and 13. It's around 1,800 light years distant. And new Fornax is a really interesting star. It's a variable star. It's blue-white, and it is visible to the naked eye with an apparent magnitude of around 4.7. It's 370 light years from the sun, and it's moving away from the sun. It's got a radial velocity of 18 kilometers per second. It is a candidate member of something called the Pisces Eridanus stellar stream, which is a stream of stars that are probably left over from some kind of a collision with another really small galaxy or a dwarf galaxy, and there's a stream that's getting pulled out of the Milky Way. And they think that this star was a member of that stream. And based on that, they think that the age is around 120 million years. The object is an AP star with a stellar classification of B9, 5, 3, SPSI, whatever. So it's a B-type giant star, and the SI means it has a huge amount or abundance anomaly, if you like, of silicon. It is a variable star of what's called alpha Canum venatorum type of variable. I don't exactly, I've never looked at one of those. It ranges in magnitude from 4.68 down to 4.73 with a really short period of 1.89 days, which happens to match its rotational period, which is interesting. It's a little over 3.5 times as massive as the sun and about 250 times as luminous, and it has about 3.5 times the sun's size. Okay, so those were what I thought were the more interesting stars. There probably are others, but that's all I could dig up. Now, in terms of deep sky objects, because you're looking straight up out of the galactic plane, and you're not looking through very much of the Milky Way, Fornax turns out to be really rich in deep sky objects, most of which are other galaxies not connected with the Milky Way. And some of them are very important for today's research. So I'll go through some of the deep sky objects. The list was really long, and I picked out, again, what I thought were the most interesting ones, or the prettiest ones. So like this one, NGC 1097 is the only one that's actually marked on this chart. It's a nice barred spiral galaxy at magnitude 10.2. And it's located around 45 million light years away. That's a nice Hubble picture of it. One of the Milky Way's satellite galaxies is located in Fornax. The Fornax dwarf spheroidal it's an elliptical dwarf galaxy, and it is one of the satellite galaxies in the Milky Way. It was discovered by Harlow Shapley back in the 30s while he was in South Africa. And it was discovered by taking a picture. The galaxy contains 6 globular clusters, and one of the globular clusters was actually discovered before the galaxy itself, because the globular cluster is actually pretty bright. The galaxy itself is very difficult to see. The stars are not very bright, and it's hard to see with an amateur telescope, almost impossible. And the galaxy is receding from the Milky Way at 53 kilometers per second, and is made up mostly of what's called population 2 stars. So it's old. And it's located in the middle of that red circle. This is the bright globular cluster that's in that galaxy, NGC 1049. Really bright globular cluster. It is visible in moderate sized telescopes, got a magnitude of 12.9, so you can see it with a reasonable telescope. And this globular cluster was discovered almost 100 years before the galaxy was discovered. And then there's a nice planetary nebula in Fornax. It's called the Robin's Egg Nebula, because it looks like it's got the same color as a robin's egg. And NGC 1360. The central star of this planetary has been confirmed that it's actually a binary star, which is unusual for a planetary nebula to have a binary star as the central star. And it's at magnitude 9.4, so it's fairly easy to see in a modest telescope. And by the way, I didn't write it down here, but when I was finishing up my slides, I found out that this nebula here is actually about 4 times the size of the Ring Nebula. So this is a fairly large planetary nebula. I might go looking for it next year, because I haven't seen it. And it's not that far south. It's at about minus 25. So we look at things that far south all the time. This galaxy, NGC 1365, has been called the Great Barred Spiral Galaxy. It's at 56 million light years, and the reason it's called the Great Barred Spiral Galaxy is take a look at that picture. Look at that bar in the middle, that big, thick yellow bar going from left to right. That is a really thick bar for a barred spiral galaxy, and that's where it got its name. So they know that this thing has a supermassive black hole at the center, and it's about 10th magnitude, and it's in what's called the Fornax cluster of galaxies. There's a cluster of galaxies in Fornax, like the Virgo cluster, which I'll get to. And it's located down here in that corner down there. And then you've got this guy, NGC 1316. This guy is also known as Fornax A. It's about 60 million light years. And this is a bright radio galaxy. This thing is at 1400 megahertz. This is the 4th brightest radio source in the sky. It's very similar to Centaurus A. Kind of looks like it too. It's down there in that red circle. Now you've got what's called the Fornax cluster. This is a cluster of galaxies lying at a distance of about 19 megaparsecs or 62 million light years. The total mass of this cluster is about 7, give or take, times 10 to the 13th solar masses, making it the 2nd richest galaxy cluster within 100 million light years, after the Virgo cluster being the largest. It may be associated with another group called the Eridanus group. Not sure of that. It's mostly in the constellation of Fornax and a little bit overlaps into Eridanus. And it covers an area of the sky about 66 degrees in diameter. It's a valuable source of information about the evolution of clusters because it's relatively close. It's a lot closer than the Virgo cluster. And it shows the gravitational effects of merger galaxies and galaxy subgroups. So it's used a lot for studying the effects of galaxies, how they interact with each other. At the center is 1399, which is a big elliptical galaxy, and then there's other galaxies in there that are listed, and actually there's a long list, longer than this list, and 1316 is the brightest, which I think I had a picture of earlier. And so this is a nice cluster of galaxies, and there's what it looks like. So that's a neat cluster in galaxies in the constellation Fornax. Yeah, that barred spiral down at the bottom. It's one of the ones I showed you. And then another thing that's in Fornax is the ultra deep field image that Hubble took. It was an image that was taken in the constellation Fornax using new cameras and stuff to go farther and deeper than the original deep field did. And it was taken back in 2003. And it was used to search for galaxies very older and older and older, if you like. And they picked that area because there aren't any bright stars. Yeah, if you look at the chart, you can see the little red square. That's where the Hubble deep field was taken. Sorry, the ultra deep field. And there's no stars in that area. So they picked an area that was pretty much empty. And that's the picture they got. of the Hubble Ultra Deep Field. Oh. And that is my last slide. Any questions on Fornax? That's it.
Thank you, Doug.
I'm going to stop sharing. Okay.
And moving on to the main topic for the night, which can everyone see my screen?
Yep.
Cool.
Yes.
So as I kind of mentioned in the intro for this, so the NGC catalog is one of the most commonly used catalogs by amateur astronomers today. It and the Messier catalog basically form the backbone of just about any observing list for those interested in deep sky objects. So knowing about it, so this gets a lot of importance in knowing kind of what's on it, what it's about, and a little bit about what the history is. So the NGC catalog stands for New General Catalog. It is one of many deep sky objects, deep sky object catalogs from Messier, Caldwell, Shapeless, or Sharpless, IC. There's just so many catalogs right now for various things, and as we get more and more out there, a lot of them are becoming more dedicated to photographic objects, putting them out of the reach for the visual observers. But some of the older catalogs, such as Messier, NGC, and a couple of others, do contain a lot of really good visual objects. Making it a good source for just finding things you want to look at on any particular night you want to go out and observe. Other catalogs often are built from elements within the NGC catalog, such as the Caldwell list. But the Caldwell contains a mix of mostly photographic objects and some really cool visual objects, which we may see later on. There are we've got zoom overlays all over the place for me. Give me a second. There are a sizable number of items that are both open to us, both visually and photographically. It's kind of a mixed bag though, because the object list is so big. There's a lot of things that are too small to see with our equipment, or at least within reasonable equipment that you might have stashed around. When I talk reasonable, I typically say anything between a 10-inch or lower telescope, just because things higher than that are a little bit pricey. I like to keep my telescopes in the realm of not breaking the bank when we go buy them. Many of the objects that we look at in the night sky tonight, or that you might see on other websites, are pulled from the NGC catalog. And the catalog is so often used that if you see, as you may have also seen in the picture Doug had earlier of the star charts for Fornax, you'll notice that there were just numbers in a couple of spots on that. Those were NGC objects, and we've gotten to the point where we just leave off the NGC prefix when on many modern star charts, because we just assume it's from the NGC catalog. Come on, next slide. Kind of giving another idea here of what we mean. So the 663, 475, 147, 185. These are all four of these items are NGC catalog numbers versus M103 and M52, which are clearly Messier catalog. So, quick and easy to find on star charts. So obviously, with new in the name of the catalog, there was something that have come before it, and indeed, the NGC's predecessor catalog, known as the General Catalog, was assembled by the Herschel siblings, the Herschel family, over a course of over 100 years, with Will and Carolyn Herschel, Carolyn Herschel, who were brother and sister, publishing the first draft of the NGC catalog in the 1780s. A short time after, Messier published his catalog, which, considering that, there's about 1,000 more entries in the general catalog compared to Messier's comparatively small list, it's kind of a funny just how quickly things grow in the night sky as new people start looking up. And the first, as the general catalog contained about 1,000 objects, all of which were individually plotted and observed by both Will and Carolyn. Both they published a series of revisions to the catalog, correcting small things such as stellar coordinates over the next, cataloging new entries that the pair found over the next 30 years, until eventually William's son John was adding, who became a very important astronomer and physicist in his own right, much like his father, added about another 2,500 objects. So just between the Herschels, about 5,000 objects in the night sky were cataloged by this family. So hoping to do a couple of presentations coming up about their contributions, because there's a lot of stuff that these three have done for the astronomy field. The last Herschel edition of the catalog was published in 1864, about 80 years after the original published date. So it goes to show just over how long this catalog was built. At the time it was completed by the Herschels, it contained about 5,000 objects. Quick portraits of the Herschels, going from William, Caroline, and John. Hopefully I'll have some presentations to talk more about them in coming meetings. So moving on from them, we then have to segue over to John Louis Emil Dreyer. Dreyer. He is a Danish astronomer and worked in a couple of other observatories until he eventually worked his way over to the Armagh Observatory in Northern Ireland, where he proceeded to work at the observatory from 1882 until his retirement in 1916. He published he was the first person to publish a supplement to the general catalog before the Royal Astronomical Society basically said, stop doing that, just go make this bigger catalog on your own. And so he did. He spent about 2 years compared to the 30 plus years that the Herschel system took to build the general catalog, and basically used a whole bunch of references and other existing catalogs to assemble what became the first draft of the NGC catalog, which he published in 1888, and I think it was the letters for the Royal Astronomical Society. This is an aerial overview image of the Armagh Observatory as it stands today. It has a notable distinction of also having the longest continuously run weather observatory in the world, with observations dating back, I think, to the 1700s, the early 1700s. So still an active place today for research, although maybe not necessarily what it was originally created for. Part of the impetus for creating this new catalog is by this point there were so many people floating around their own private catalogs with things not on them, things not on them. As we eventually found objects that were just never there in the first place, because they may have been defect artifacts and telescopes for research equipment used by the astronomers of their day. But the goal that Dreyer kind of set out for himself was he wanted to make the catalog that contained nearly every known deep sky object in the sky at the time. And that part he was successful all for about 5 years, when eventually new objects were found. We obviously, given the number of things today, we still have the same problem of just being able to find things in the night sky that are interesting to look at. And computers have helped quite a lot here, just being able to Google is like, what are some things I'm going to go look at in the night sky? But the need to be able to find useful and interesting things continues to be a problem for us today, both for amateurs and professionals, because there are just so many things. The final result of Dreyer's work pulled from about 50 other catalogs, collections, and papers that were published by various astronomers. He, for some reason, decided to organize his objects by right ascension. And the catalog that he originally published spanned over 250 pages, front to back. And as I mentioned a second ago, it contained every object in the night sky that was known at the time, totaling about 7,840 objects. And since Dreyer assembled this over a 2-year time span, he didn't have time to go and look at all objects in his catalog. He kind of just had to take things on face value from the materials he was looking at, which led to the original catalog containing items that didn't exist or were, due to typographical errors in the papers and materials he was pulling from, contained misplaced locations, right ascension and declination coordinates. Most often the error would be that they flipped the sign on the RA on the declination value, so that instead of being in the northern hemisphere, the object was in the southern hemisphere, and vice versa. Sometimes they're also brought about by his own error. For example, NGC 2163 was cataloged as non-existent because by Dreyer, when it was cataloged by the Herschels, because he made an error in his when he was copying the data over from the source materials. This is kind of a snippet of Dreyer's original publication, which was again published in the 1980s. So we do have some modern typographical fonts to deal with conveniently, instead of handwriting in cursive and other, instead of personal handwriting, which would most have been common by the Herschels. On the right hand side here, there's a summary description. These are actually encodings to represent the specific types of objects, and I forgot to actually include a slide explaining what the encodings are. But this was basically an astronomer's shorthand for being able to code like, hey, this is a planetary nebula, or this is a galaxy, and so on. Just because, writing out galaxy in such a small space is, very difficult. After Dreyer published his, there were a couple of other extensions that have been added to the NGC over time. As shown in Doug's presentation earlier, there are a couple of newer objects that have been added to it over time, such as the dwarf galaxy in Fornax that he mentioned. That's actually a dwarf galaxy of the Milky Way itself. So there continued to be extensions to the NGC catalog well after Dreyer's publication. But even while Dreyer was alive, he continued to publish some new catalogs as well, also creating what's known as the IC catalog, which contains almost exclusively photographic only objects. Because coming in here at the end of the 1880s, as he did, with the people finally deciding to take cameras and point them at the night sky with their telescopes, started to actually catch on both for professionals, which led to him creating a second catalog with all these new objects that people were photographing of. More recently, there have been some more modern revisions to the NGC catalogs, starting with the NGC 2000 project, which set about correcting some of the errors in Dreyer's original work, adding some of their own errors too at the time. Then the more recent NGC IC project, which went over through deep sky survey data provided by Palomar Observatory of all places, and gave accurate observations for every object in the NGC and IC catalog, in confirmations and positional data that we get from having a lot more modern telescope systems. So the kind of confusion that comes to me is, you have all these different versions of the NGC catalog. So it's sometimes kind of a question of which revision am I looking at? And I think if you're having a go-to telescope, it's either using a combination of the NGC 2000 data or the NGC IC project, depending on what year your telescope was manufactured in. Oh, that was a placeholder slide I forgot to fill out. My apologies. So Dreyer was also notable for a couple of other contributions he made. He was an avid historian of astronomy as well, assembling one of his own autobiography, excuse me, a biography of Tycho Brahe, and also organized and published many of Tycho's private correspondences in a humongous 15-volume collection. With that's just a lot of work for one person to do. So, passing on some of the observations of Tycho to us today. He also created essentially one of the more recent histories of astronomy, which has now printed as a history of astronomy from Thales to Kepler. And I think it's printed out of the Cambridge University Press. And he also co-edited the official history of the Royal Astronomical Society. So some really cool works for those who like to know more about, a history of the astronomy hobby as a whole. You may very well find works written by John Dreyer. Circling back, with the objects in the NGC, the NGC catalog containing as many objects as it does, contains basically every type of D-sky object you could want. There's globular clusters, open clusters, emission and reflection nebula, planetaries, asterisms all over the place. So there's definitely something in the catalog to satisfy just about any type of observational preference that you might have, whether you find yourself as a deep sky object person or a multi-star systems. There's something in there for in the NGC catalog for you. It's just sometimes a matter of finding it. This is another slide pulled from the original publication of the NGC catalog, showing just a list of the sources that Dreyer had pulled from in order to make the catalog. Some names that we might recognize, like Herschel, and some more other recent ones that we may make interesting conversations on topic of conversations in future meetings on their own. We'll have to see, but that was one of the things that set his catalog out apart from others, is that he actually cited all the sources that he pulled them from, rather than just like, hey, here's this collection of things. So we've actually gone back to those original publications to help cross-verify some of these objects over time. Being assembled, being assembled during the time period it was, telescopes ranging from 2 inches all the way up to a mammoth 72 inches were used for catalog the original NGC catalog. So that definitely stuff in there that starts to push outside of the range of what amateurs would be useful towards, what would be accessible to amateur astronomers today. I think the dimmest object I've seen in the NGC catalog goes all the way up to magnitude 8 Cain, and the average limiting magnitude for an 8-inch Schmidt Cassegrain is about magnitude 14. So definitely one of those things to watch out for is, making sure you're getting objects that you can actually see. Some of them also in the catalog tend to be very dim or small in angular diameter, so you might end up picking things that are like 3 arc minutes or smaller, which is something. So just some small mind traps to watch out for. But many of the original items cataloged by Carolyn, William, and John Herschel are all generally accessible to amateurs today, just because of the equipment that they were working with. And as with that last item, as I mentioned earlier, your go-to is likely pulling from the NGC 2000 catalog. And this is just a short list of NGC objects that I've observed in my own time or photographed. All of them are pretty good. Some of them can be quite large, like the Rosette Nebula, which spans almost 1 square degree, or about 2 full moons. But most of them are quite good in an 88 Schmidt Cassegrain, more similar comparable telescope. There's also an interesting link down here that pulls up a list of about 110 other notable NGC objects that you might find interesting. You can also just Google it real quick, but definitely something to look at. The objects in here are all named objects. That's by far not the norm in the NGC catalog, where many of them just have a number. So named objects are if an object does have a name, it's usually one that's generally worth looking at. And that's it for me. Any questions?
Yeah, Connor, what happened? Where does the RNGC catalog fit in? Do you know?
That's I saw that it's an extension of
We have a copy of it in the library, and I have a personal copy myself.
it's like the revised NGC.
Well,
It's
that's
another one of
exactly what it stands for, but where does it fit in the history? Is it something?
It was done before
1975, I think, was when it was published.
it was done before the my
Before
brain,
the 2000.
yeah, it was done before the NGC 2000 project. I didn't include it just because obviously a time, and the NGC
Not
2000
used
was more
anymore.
recent, and
Yeah,
it's one of those historical artifacts rather than
okay.
versus the last two NGC 2000 and IC projects were ones that I think are what most modern NGC catalogs are based off of today.
Okay.
But it was assembled, I think 73 is when it started, or when it was completed, one of those two.
Yeah, because I got it. It's 75 is the copyright date on it.
Yeah, that sounds about right. But yeah,
So it was some kind of in between, you might say.
it was I think the first attempt to try to clarify a lot of the errors and see what things in it are, because as I mentioned, there's a lot of errors in the original NGC catalog of things that didn't exist.
I think it was an intermediate step, because it also contains the index catalog objects. So I think it was some kind of an intermediate step here. But obviously it's not used anymore.
Well, I'm pretty sure there's some research paper out there that that continues to use it, just because why not?
Yeah, maybe.
But excellent question. Anyone else?
Yeah, who is anybody adding anything to these? What would make another project? Who would be responsible for that?
So most catalogs can be made by just about anybody. Like, for example, the Caldwell catalog, which I kind of mentioned early in the presentation, is actually one of the more recent catalogs that was created by an amateur astronomer. It was published in like the mid 90s. So there's no real formal governing body around catalogs. Most of them typically come to us from, large telescope surveys of the night sky, like you might get with the Sloan Deep Sky Survey, and that sort of thing. So they typically might get cataloged with whatever with whatever telescope or sky survey generated the data and catalog that entry. But other than that, you could certainly go out and make your own, which is what Caldwell did with his when he published his in Sky and Telescope in the mid 90s.
So most of the new objects that are discovered nowadays are discovered using, like Connor said, professional observatories are discovering new objects all the time, and Hubble discovered lots of objects. They usually have very complex names, because the names are usually a series of letters and a series of numbers that translate to a particular survey that was done with a particular instrument at a particular time, and they're just numbers. I was looking at the constellation Fornax, and there were some oddball objects in there that had things like GCF1A.632.3222, those kinds of things. and they're meaningful in the sense that you can look them up and find them online, and they're done through a survey from a professional observatory, and that's their way of maintaining their list of new objects. And no one's putting together any new catalogs that I know of.
So are things with a name starting with an H discovered by Hubble?
No, not necessarily.
Not necessarily. It's one of those things that causes a lot of confusion to amateurs. Just because you have to look up what the catalog actually
have to track it down.
Yeah, which could be a little bit of a legwork, but usually fairly quick now when you can just Google, here's my catalog number, and then usually Wikipedia will point you in a good direction fairly quickly, or you might, if you're unlucky enough, they'll point you just to a research paper, and then you have to read through that, which doesn't happen very often, but can.
I don't know if anyone will ever put together any new catalog like the NGC, because the catalogs that are currently existed, like Caldwell and the Messier and the NGC, are predominantly used by amateurs now, and I can't imagine an amateur astronomer putting together another catalog that goes beyond the NGC.
Yeah, I was kind of specifically thinking about, all the discoveries from Hubble. Do they have their own?
They have an official designation that's approved by the IAU, the International Astronomical Union has to approve all names.
I forgot about that. That's right.
It's just some designation that they use for, Hubble or for Sloan or for, they have those designations, I said, that are very complex, but they have a meaning and they're unique. So.
And it's very rare that you'll have an object in the sky that has only one catalog designation.
That's true.
Like the Andromeda Galaxy has like 35.
Yeah, that's absolutely true. But the new objects that are be discovered by Hubble and things like that might only be visible in Hubble, so they might only have that Hubble designation.
So, with that,
well, something that's totally unrelated to the subject is that maybe it'll be clear enough tonight to see some meteors.
Well, keep your fingers crossed, Kay, but I'm not.
My weather app currently says cloud, all the way up until I can't see past it anymore till tomorrow night at 6 p.m.
Oh, we're just cursed in being able to see the Perseids. Every year it's the same thing.
It's always monsoon season during Perseid meteor shower.
Looks
That is the
clear at
problem
my
with
house.
living here in the middle of where monsoon comes in the summer, is you miss the summer stuff.
Well, it was pretty clear outside the last time I looked. So maybe.
That's
Yeah, it's
definitely
still
the
clear.
exception rather than the norm, though.
I'm
I'm
in North
looking at-
Tucson.
A lot of clouds right now.
So that's all I had. I was hoping for a little bit more people on tonight because I wanted to also discuss, some ideas about what we might want to do after we finish all the constellations.
Let's go ahead and discuss it, even though you don't have a huge crowd. There's no reason we can't talk about it.
It's kind of one of those things that we had kind of started floating some ideas around last semester. I'm going to go ahead and end the recording here
Okay.
for this.